Okay, so welcome to Trust the Process. In this video, we'll be talking about question 3 of tutorial sheet 2, PHY 102. The question reads, a spring of negligible mass stretches 3.00 centimeters from its relaxed length when a force of 7.50 Newton is applied. A 0.500 kg particle rests on a frictionless horizontal surface and is attached to the free end of the spring. The particle is displaced from the origin to x is equal to 5.00 centimeters and released from rest at t is equal to 0. Okay, so the first question is saying, what is the force constant of the spring? What is the force constant of the spring? So now, when you are dealing with a block spring system, we know that we basically just want to understand the motion of the block as it is attached to the spring. So this question is in two phases. Let's focus on the first sentence. The first sentence here is saying there is a spring and there is nothing on that spring. All we know is that on this spring there is a force of 7.5 Newton that was applied, and this force was causing some extension. This force here was causing some extension of 3.0 centimeters. So the first question is, what is the force constant of the spring? So when they say the force constant, it is the same as finding the spring constant, or they might also say the stiffness of the spring. So what you have to know is the stiffness of the spring can never be negative, and hence when finding it, you are going to say the magnitude of the restoring force is given by Fkx, where we know that the K will just be equal to the force over that extension. So now, if you see in the question, the first sentence, they are saying that this force of 7.5 is the one that caused the extension of 0.03 meters. When you convert 3 centimeters into meters, you have 0.03 meters. So basically, this is how you find the extension and the spring constant, and clearly it can be seen that the spring constant is just going to be measured in Newton per meter. So that is it. Then the next part of the question, it's now involving a particle being attached to the spring. So after it is attached, it was displaced by 5 centimeters. That is what the question is saying. So since this is the furthest the particle was displaced, we can also call this one as our amplitude. That is the furthest the particle was displaced. So meaning, according to the data on the second part of the question, they are saying that this particle has a mass of 0.5 and it was displaced to x is equal to 5.00 centimeters from the origin. So its amplitude is 0.05 meters when you convert that into meters, and then it was also released from rest at t is equal to 0 after being stretched like that. So the question B is saying, what are the angular frequency, the frequency, and the period t of the motion? So if we consider this question, they are saying of the motion. The motion, they can't just say the motion if you're dealing with a spring alone. Meaning, they are talking about the motion of the particle. How is the motion of the particle going to be if the spring is the one responsible for its motion? So how do you find the angular frequency? Angular frequency is given by the root of k over m. And the k is what we have found there. M is the mass of the particle. So you have the angular frequency, which will be measured in radians per second. That will be the angular frequency. Then how do you find the frequency? The frequency is related to the angular frequency by angular frequency is equal to 2 pi f. So making f subject, f is equal to angular frequency over 2 pi. That is what we have. So our frequency here is just going to be given by the angular frequency divided by 2 pi. where the angular frequency has already been calculated for, and 2 pi is a constant which can be punched on the calculator. So as you are punching these values, it's okay for your calculator to be in degrees. Nothing is going to be affected. And then the period, we know that period is equal to 1 over frequency, and we are just from finding the frequency, so the period will be given by that, which will be measured in seconds, and then that one will be measured in hertz. Okay, now part C of the question is now talking about finding the amplitude of the motion. What is the amplitude of the motion? So the amplitude here is just going to be the furthest this particle was displaced. So you never have any other displacement which would be greater than 5 centimeters. Hence, the amplitude is just 0.05 meters. This value has to be converted into meters. Part D. What are the maximum velocity and maximum acceleration of the particle? What are the maximum velocity and maximum acceleration of the particle? So, finding the maximum velocity, the Vmax is given by the angular frequency multiplied by the amplitude. The angular frequency has been calculated, the first part of part B. Then the amplitude has also been given. It's just a matter of plugging in the values and punch. So this one is going to be meters per second. Even here, as you are punching, your calculator can just be in degrees. It's okay. I am going to make an emphasis on when to convert your calculator into radians. And then we know that the maximum acceleration is given by omega squared multiplied by a. So you know the omega, you know the amplitude, plug in the values, you'll be able to find the acceleration, which is measured in meters per second squared. Alright, part E of the question is saying, part E and part D are the same, so let's go to part F. Part F is saying, determine the displacement x of the particle from the equilibrium position at t is equal to 0.5 seconds. Determine the displacement of the particle from the equilibrium position at t is equal to 0.5 seconds. So how do you determine the displacement of the particle when time has been given? Now let's consider a block spring system. So this is the first scenario where we are saying it is at x is equal to 0. Then the second scenario, we have stretched the spring. The third scenario, it is compressed like that. So this is the point x is equal to 0. That can be x is equal to the maximum displacement, and then that would be the minimum displacement. So clearly it can be seen that the motion of the spring can never start from 0. Yes, this spring is going to produce a simple harmonic motion. It is more like a simple harmonic oscillator. So the motion of the spring can never start from 0. In order for this spring to start vibrating, we need to displace it. It is either you stretch it and let go, or you compress it and let go. That's when it will start vibrating between negative A and positive A. So just as it is, it cannot vibrate on its own. And that's the more reason as to why we say, since we have two types of periodic function, there is a sine function which starts from 0, then there is a cosine function that starts from 1, or whatever amplitude you have. So a standard sinusoidal function that is going to be formulated by a spring is going to be a cosine function. Okay, so this is going to be a cosine function, and that is the more reason as to why when finding the displacement, you say the displacement is given by the amplitude cos omega t. For the sine function, yes, there are some questions that can have a sine function, but a standard one for a spring is going to be a cosine. Why? Because for this motion, you need to start at a certain value, and that is exactly what happens for a cosine function. It doesn't start from 0, instead it starts from A. So if this is the point A, then we're going to say this will be the first turning point, which is negative A. and that is going to be A, where this now is the point where the first complete oscillation will be made. So our standard sinusoidal function produced by a spring is going to be x is equal to A cos omega t. Now this equation means you can be asked to find the displacement of the particle maybe at this point. So how do you find the displacement of the particle at any point given the time? So when you're given the time, you're going to use this equation, provided you have the amplitude, you have the angular frequency, and you have that time, you can find this displacement. So according to this question, we already know the amplitude from the previous questions, we know the angular frequency, and we've also been given the time, which is 0.5 seconds. So just plug in the values and punch. But as you are punching this, look at this. This is cos omega t. So our angle there is omega t. And we know that omega is measured in radians per second. Time is measured in seconds. So meaning our angle is in radians. When you are punching this into your calculators, make sure that your calculator is in radians. Just convert your calculator into radians, and all the quantities are going to be plugged in as they are. Don't convert any quantity as long as they are in their standard form. Just convert the calculator into radians. Alright. Don't forget to convert the calculator into radians. So this is displacement. The moment you differentiate displacement with respect to time, you are going to have velocity. So dx dt, the reason why I'm saying dx dt is the function is x, which is depending on time. So dx dt will be equal to our velocity, which is equal to the derivative of omega t is just omega, so we multiply by what is in front there. Then derivative of course is negative sign, that's why we have a negative. So it will be that. That is how you find the velocity at any given time. So it will be amplitude multiplied by the omega, which is the angular frequency, then sine, angular frequency multiplied by time. Don't forget a negative. So this is how you find the velocity at any given time for a sinusoidal function made by a spring. And then how do you find the acceleration? The acceleration, you just need to differentiate the velocity. So this will give you the acceleration. And derivative of omega t, again, we are going to have omega. So here it becomes omega squared. Then derivative of sine is cos. So you're going to have cos omega t. And even here, as long as you have amplitude and the angular frequency, even the time, you can find the acceleration. So this will be meters per second squared, that will be meters per second, and that will just be in meters. So all these three equations, when you are solving using these equations, make sure your calculator is in radians. Don't forget, if you don't know how to convert into radians, you can just punch on mod. The first time you're going to have 3 options, then punch again on mod, you're going to have again 3 options, then press on 2, because that is where radians is. So after pressing on 2, the display there on the display, you should have something like a capital R on it. And if you want to see that you are successfully converted the calculator into radians, make sure you punch cos pi, and this should give you -1. Alright, thank you for watching.